So, two things when we're dealing with word problems. Don't come to them blankly. Okay? You guys help me out here. In this chapter, what are some things we've been doing? Yeah?
Slope.
Okay, slope. So, m, little m, y2 minus y1 over x2 minus x1. Okay? Other ideas. It's good. Yeah?
Like different ways to write an equation.
Okay, different ways to write an equation. So we had slope-intercept form. If they give you the slope and the y-intercept. What is the y-intercept? Like, how do I know what point is that? Yeah? Okay, where it crosses the y-axis? Absolutely. And if I'm looking at an ordered pair, how do I tell it's the y-intercept?
The y-intercept is always going to be 0.
Yeah, when x is 0, y equals whatever the y-intercept is, right? So, and then there's one other type of line. You got slope-intercept and then the other one? Yeah? Point slope. Okay, so like, thinking through those things as I approach a problem like this, all of this having to do with graphing, right? Like, helps me to come equipped to do this problem. Okay, because I'm not approaching this problem like blank-minded. I'm like, okay, I'm going to graph something, I'm going to write an equation of a line, or I'm going to talk about, like, we're talking about those things. So keep that in mind. So when you get to the problem, you're like, okay, great. They are asking me to draw a line. All right, I just have to graph something. Okay? And they give me the x and y intercepts. Do I know how to graph by x and y intercepts? Like, what coordinate is this? Mason, you just said this. For the y-intercept, what has to be 0?
X.
The x. So if x is 0, y is 20. So I could go on a graph, and I could graph 25 here. We'll go by 5s. There you go. And this guy right here? Yeah. What point is that?
25, 0.
Yeah, 25 comma 0. So we've got, like, we'll go this way, 5, 10, 15, 20, 25. There's a point there. And they wanted me to graph this, and it says the rate, let me say this, let me do this. The rate is another word for slope. Slope is sometimes called rate of change. Okay, so slope. So it's going down -1. So it goes down 1 over 1, down 1 over 1. If I go down 25, how far over should I go? 25, right? There's my line. So they want me to graph. Now I would probably want to, because this problem is talking about something, put like some context to it. What is the y? What do the y values represent? Yeah, dollars. Some dollars here. And what do the x values represent? Yeah.
Songs.
Songs. Okay, context. They said describe a real life problem that has given the given rate and intercepts. Okay. Yeah.
Each song is $1.
Okay, so you're downloading, you're buying songs, each one costs $1. If you want to get crazy, you could be like, I walked into class one day, and I started paying Mr. Shanks $1 to play a song on his guitar. And since he only knew 25 songs, I paid him $25 to play all 25 songs. Does that make, like, this is just me being crazy, right? I think what they're talking about is probably like, something like iTunes, where you're downloading a song and you're paying money for it. So, yeah.
So, like, on a test, you could do just something like that that's...
As long as it, like, fits the context, it could be a little crazy, yeah. Yeah. So you have some creativity there, It's like, tune in? Is that the word I'm looking for? Hone your writing abilities, and creativity on your math test. Right. So feel free. Right? It makes it fun to grade. And I'm not just like the same answer every time. Okay. All right. Here, notice this, and I want to make sure we read everything. So it says graph, so we're going to graph. Interpret. They're not telling me to give them numbers. They want words. And then the last one is find something. Okay? So I can graph. We've talked about graphing. Interpret. And this is going to be where we're going to focus for today, I think, because that's the most different part. And then the last one, okay, let's focus on that for a second. You have to read the whole problem to understand, so we're going to back up and go back and forth. But after how many hours? So they're asking us for how many hours. Can you guys look at the top? What letter represents how many hours? Yeah. X does. So what are they asking us to find? X. Is the battery power at 75%? They gave us a number. What represents battery power? Y. They're giving us Y, and they're asking us for X. I don't think that's something that's crazy for them to ask you. It's not something you've never done before. But you have to see that when they give you this, you have to read that. So when you get to these word problems, I broke it. I really did. All right. When you get to these word problems, you need to be thinking through what does everything mean as you start doing it. Okay? So, first off, they ask us to graph, so let's graph. And I'm thinking through this right away. I'm going to label this. I want us to start. What is Y? Here's the Y-axis. What does Y represent? In this problem. We're thinking context. Yeah. Okay. It's the percentage in decimal of battery power. So I'm going to put percent of battery. And I'm going to put in parentheses decimal. So they give us some different numbers. We'll talk about that in a second. Okay. Down here, what's on the x-axis? What does x represent?
Hours.
Okay, it represents hours. In this case, specifically, hours after you turn on your laptop. So here you are. You get to school today. Okay, over the long break, and you are getting ready for what class do you have later? IT? Personal finance, okay? Alright, personal finance. And I don't know if your teacher ever has you use your laptops, but we'll pretend that today you're supposed to have your laptop ready to go. Okay? So yeah, that's what I was thinking IT. But that's fine, we'll do personal finance. It doesn't really matter. So here's the deal. You're sitting there and you're you open your laptop and all of a sudden you realize, I only have 5% battery life. Well, not personal finance. Okay? So, this is the situation. You're kind of okay, I clearly forgot to charge it over break. I just left it in my locker, and the battery's just been slowly draining because it just doesn't just magically stay in there, right? Even if I haven't used it, right? So this is the dilemma we're in. Okay? So we're trying to think through those things, and this is the context that we're talking about. So then they ask us to graph it. Well, what is this guy right here? Yeah.
How much does it start out with the Y?
Okay. The Y intercept, and it represents, it says 1, but that's in decimal form. So what percentage is that actually? Yeah.
0.01 or 100?
It's 100. You're on the other. It's 100%. So I'm going to put that at the top because your battery's not going to have more than 100%, right? So I'm going to put it at the top because my battery's only going to go down, and I can tell that because my slope is negative. And how much is my slope decreasing by? Yeah, 20%. So I'm going to start at 100 or 1, and I'm going to go by 20. Sorry, I did not space those super well. Okay, I apologize. That's not really helping. All right. There you go. Okay. Yeah.
For the x-axis and the y-axis.
Yes.
First of all, going up, wouldn't there not be an arrow? Because it's not really going on forever because it can't go higher than 100.
Technically, we always put arrows on our axis and axis. I didn't here just because I'm sketching it real quick.
Okay, but
But yes, I understand.
with the problem.
Yeah. Technically, we still put them just because it's a graph. you don't have to use all of it, and you can recognize you're not going to go beyond certain restrictions, right? We're not going to go below. It's not going to have negative percentage or negative hours. Okay. And so I have that. So it's asking me, I'm trying to graph this. So I started here, I put my dot, and then I'm going to go down 20% or 0.2 for every 1 hour divided by 1, right? 0.2 over 1. Everything's divisible by 1. So down 0.2 over 1. 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 I didn't do the best job there. Okay, and there's the line. And again, I really would stop here. This is not going to go past that, and I'm not going to go below that. So it's kind of restricted. But this is kind of like our graph. Okay. So notice, and I'm going to do this right now for down here, my y-intercept is 0, 1, and my x-intercept is 5, 0.
Why is it crossing the...
It's not. That's what I was saying. It's going to stop.
Well, like at the 5, because...
It's not crossing it. It's going to stop.
Well, yeah, but like... Wait. Because... Oh, because you need to do even below the 2, right?
Well, yeah, until it's empty, right?
Yeah.
And again, I'm even hinting at what we're doing. So it says interpret these. Interpret doesn't mean write down this, 5, 0. And it doesn't mean write when x is 5 when y equals 0. No. We want in context. Please understand this. 5, 0 could mean anything depending on the context. Does that make sense? It can mean lots of different things. Okay? I'll give you 5 lollipops for $0. I'll make you run 5 laps for free. Okay? I mean, I don't know what it means. Right? So as I'm looking at this, what they're asking when they say interpret is tell me in this context, in this problem, what does this mean? What's really nice is that if I'm the interpretation will be the same. Okay, so what I'm going to do is I'm going to write a general interpretation, and we're going to plug in specifics. Uh, 0 hours, or blank hours, after I turn on my computer. Laptop, right? What did I just write? Where did I get this from? Please don't think I'm pulling it out of thin air. It's coming from somewhere, yeah.
From each side,
Okay, from the graph?
Yeah.
But where did I get this from? From the bottom of the... Okay, I almost copy-pasted this from the instructions at the top, right? X is... the one thing I put is I put the word I in there. Okay? Where did I get this from? Yeah. Ella, go ahead, yeah. Okay, at the very top. What does Y represent? Percent in decimal form of?
The battery.
Right, of the battery. Yeah.
Is this implying that we start with 100%?
It's not implying. It told you that. Okay, where did we get this point from? Yeah.
The word problem was at +1.
Okay, the equation of the line told us plus 1. So that's the y-intercept. So technically that's the starting point. Now, let's say you didn't start at that amount. It's still after how many hours after the number of hours after you turned on your laptop, right? So even if I turned it on once 10 hours ago, fast forward, and then I'm turning it on again, is it going to be at 100% anymore? But it's still certain hours after I originally turned it on. Does that make sense? So that's where your assumption is coming from. It's after that first initial time. That's where it's
Would there ever be like a time where instead of giving you like 100%, it was like starting at 60%, but it still went down 20 over 1?
They totally could do that, yeah.
And then would you have to draw the line like backwards from that as well?
It would just be starting from here and go down.
Well, could they have it where it is now? And then you work backwards to make the y-intercept.
Oh, to figure out what? Sure, they could do that. They would have to say, yeah, like 2 hours in, if you're at 60%, where would you be at? Yeah. So notice what I did here is all of a sudden now I'm just plugging in the numbers they gave me. So in red, that's the x-intercept, right? 5 hours after I turned on my laptop, I have 0% battery left. Okay? I'm out of luck, my computer just died. If you want to phrase it that way instead, I'm just trying to give you one way to do both, right? If you want to sit there and like be some creative in the way you write this, you know, like I now have an F in history because Mrs. Burkholder gave me detention. You know, my computer wasn't charged. There, you know, make sure you talk about the computer battery. But like the idea is there could be consequences for that, right? The y-intercept, 0 hours after I turned on my laptop. I just got back from fall break. I charged my computer the entire time. Okay? I just turned it on for the very first time, and I have 100%, sorry, I should have written that, 100% of battery. Does that make sense? When they ask you to interpret, they're saying, in context of the problem we are doing, what does that mean? Yeah.
Would you have to do both? Like, would you have to write that twice to do both the x and y?
Yes. I'm just trying to write it a little shorter for time. But yeah, you would write it twice. So but the idea is, it is the same sentence, right? So there's nothing like crazy, unless you're putting a twist on it. Okay. So this one, again, we talked about this already. They gave us, or they want x, and they gave us y. So I've got this equation. Okay, I need to be really, really careful that I don't do the wrong thing here. They gave us y. Is everybody okay with that?
Mm-hmm.
Please be so careful. How did they give it to you here? As a percent. But the word problem was saying everything was in decimal form, and I'm sitting there like, if you put 75, you're going to get it wrong. And you're going to be off by like 100. Okay. So, the rest of the time, again, I don't want, like, this is nothing that you guys haven't done that we've been doing. How do I solve for x here? Go ahead, Mason. You don't. We already know what y is. It's 0.75. I don't want to solve for, you're thinking the x-intercept, which I already knew the x-intercept was 5, right? So, but I'm saying in this problem, if I want to solve for this x right here, yeah. Good. Tell me specifics. What do I do?
So,
You want to get this guy by itself, right?
Yeah.
Okay. So what do I have to move first?
one.
All right.
This one.
Then I'm going to. Yeah. Okay. Divide by negative 0.2. Hooray for that! So it's not a negative answer, right? Because that would be weird if I got negative hours. We don't want that. All right. So all of a sudden I have x equals 0.25 negative divided by negative 0.2, which is equal to 5 divided by 4. Did I go too fast?
Wait, wait.
Reduce this, right? 25 and 20. How many times does 5 go into 25? 5 times. How many times does 5 go into 20? 4 times. That's 1.25. So after 1.25 hours. Sorry, 1.25 hours.
Oh.
Yeah.
Could you also find the x by just looking at the
I mean, 1.25 on my graph. That's putting a lot of trust in my graph. 0.75 is like right here. I just think it'd be hard to tell. On a graph paper, it'd be a little easier, but it'd still be hard to tell. So if they ask me after 3 hours, yeah, sure, that would be a little easier, but 75% is a little bit tricky on this graph. So, yeah.
So the answer would not be.
The answer is not 1 hour and 25 minutes.
Yeah, because it's like out of 60, right? Okay.
Technically. So you could say 1.25 hours. That's a safe answer. If you're going to convert, be really careful because yeah, it's only out of 60, and that should be tricky. Okay. So I just want you to see like every problem's going to be a little different. If I went to the other one, so this one's very similar, almost identical, but like take a look at this one. Okay. Is there a C for this? Okay, so this one says find slope and y-intercept. Write an equation of a line. Let's say they asked you, I'm just going to write it up here. What if they asked you to interpret slope or y-intercept? We already did y-intercept, so let's focus on slope actually. So really quick, let's calculate the slope here. How do I find slope here? Yeah.
Well, you do y1 minus y2 over x1 minus x2.
Normally we say that backwards, not to confuse anyone. We do y2 minus y1. It doesn't matter, right?
Got it.
Okay, but that's fine. Okay, so sure, I'll subtract those. Okay. Can we reduce a little bit? Yeah.
Yep.
Sorry, what? Don't count.
27 over 15.
Okay, 27 over 15.
Divide by 3, which is 9 over 5. Yes, Gavin.
All right, divide by 6, right? From here, if you want to.
Go ahead.
All right. So let's say I'm going to say, like, interpret this. Okay, what does y represent?
Fahrenheit is
Okay, degrees in Fahrenheit, x,
Degrees Celsius.
degrees in Celsius. For every 9 degrees
Fahrenheit.
increase in Fahrenheit, we're going to increase
5.
5 degrees in
Celsius.
Celsius. So if they asked you to interpret this, you have to take this and recognize, for every blank of these, I do blank of these. And this is 9 and 5. So for every 9 degrees Celsius increase, why am I saying increase? Because my slope is positive. I'm going to increase 5 degrees in Celsius. Okay? Yeah.
So 9 degrees Fahrenheit is the same as 5 degrees Celsius?
No.
Oh. Then, like, why is it?
Yeah, I mean, so this is just the rate of change that it changes, but that doesn't mean that's the starting spot. Does that make sense?
Yes.
Right, because this is like kind of the 0.32, that's the starting spot. This is just how much it changes by, but for it to go through exactly 9.5, it would have to be shifted to a certain location.
So 41 Fahrenheit would equal 5